This is Precalc, Chapter 3.3, Day 1. What we're going to do today is we're going to find the real zeros of polynomials today, guys. And we're going to use the fact that we talked about the factor theorem yesterday. And remember, the factor theorem said, like problem 40 from yesterday, that if you can find a value of c from an x minus c, like the factor, when you do synthetic division, it will have a remainder of 0. So any number you find to have a remainder of 0 is a factor of a polynomial. Okay, so that's what we're talking about here. And so what we're going to do today is take any polynomial. Actually, this time it's going to be a third, fourth, fifth, sixth, and even seventh degree polynomials in this lesson. And we're going to find all the real solutions. Well, here's the problem. You set up synthetic, and if they don't tell you which one to choose, now you get to choose any one you want. That takes a long time because I could put 1 in, I could put -1 in, I could put 10 in, I could put a half in, I can put 100 in. Do I want to, though? There's an infinite amount of possibilities that I could choose that might or might not work. And if you have to do this like 20 times and you don't keep track, you might cycle through the same problem 5 times. So, this is what we'll use. We'll call it the rational zeros theorem. It's complicated. It looks complicated here because it goes back to our standard form polynomial, like you've seen now about 5 times in the last couple weeks. And it says it has integer coefficients. It has a nice positive and negative numbers as coefficients. Then it says every rational zero of p is of the form p divided by q. But where does p and q come from? P and q, guys, come from the fact that p, the number on top, is the AO, or the constant. It's the factors of the constant over q, the factors of the leading term. You guys may remember of doing this last year. Basically, what we're going to do is we're going to take all the factors of the top, divide them by all the factors of the numerator, and therefore creating a list anywhere between 2 to 20 to 30 some possibilities. Now you're thinking, whoa, 30 possibilities, that's still a long list to check. Tomorrow we're going to go over some ways to possibly throw more of those out as well. But still, 30 is a lot better to check than an infinite amount to check. So we're going to be able to go and say, hey, I know for sure 5 is not even going to be an answer because it's not part of the list. I'm not going to check it. I can skip it. Stuff like that. So, what are we going to do? We're going to do problems like this, where it says, using the rational zero theorem, aka make a list, find or factor all the factor this polynomial. So I guess there's a slight difference in words, guys. It doesn't say find the zeros, it says factor this. So in that case, you got to make sure that the factors you find have to be able to multiply back together to get the original problem. If you just find the zeros on this problem, I'm going to highlight that, you will have an issue. So, first thing I need to do is I need to make a list. This list will look like this. It's going to be P over Q, or the factors of 6 over the factors of 2. Because 6 is the last number, constant. 2 is the leading coefficient. So I got to think to myself, what are the factors of 6? That'd be 1 and 6, 2 and 3. Divide all that by the factors of 2. Factors of 2 are 1 and 2, or 2 and 1. So this is what you have to do now. Some books make you write plus or minus in front of everything because you have the plus or minus. I'm going to be nice and say you can put plus or minus way up front. I am now going to cover up the 2, and I'm going to divide all of the ones in the numerator by 1. And if I divide anything by 1, it's that number. So I got 1, 2, 3, 6. I go back, cover up 1, and divide them all by 2. I only need to add the ones that are not already on my list. 1 divided by 2. So half. That's not there. I better put it in there. Covering up the 1 again. 2 divided by 2. 3 divided by 2. 3 halves. And 6 divided by 2. So the only extra one we needed is this. What we found are 6 possible positive solutions and 6 possible negative solutions, making 12 possibilities. I personally would rather check 12 possibilities than checking things that won't work. Like a 4. A 4 will not work. A 5 will not work. A 7, 8, or higher will not work. But the answer could be -2. It could be a -3 or a 2 or a 3 or a 6 or something. That is P over Q. So now we have a list. We can now start to test that list. And we test that list using synthetic division. What goes across the top? 2, 1, -13, and 6. I'm going to drop the 2, and I want to have 0. Guys, to find my zeros or to factor, according to the factor theorem, says that if it equals 0, it's a factor. So let's keep testing until we find one. What do you think? 3? Let's try 3. Put a 3 on the outside. 3 times 2 is 6. Add them up. 7. 21. First of all, it's going to result in a positive answer, right? And a positive answer here, which then a positive plus a positive will be bigger than 0. So therefore, 3 does not work. What else do we want to try? -2. -2 times 2. -4, which equals -3. -2 times -2 is 6, which is -7. That's not going to work either, guys. Okay, everybody see that's not going to work? A positive 2? Okay, let's try it. 2. 2 times 2 is 4, which is 5, which makes a 10. -3. -6, which ends up resulting in 0. So it took us 3 attempts. Does it take time? Sure. Could you get lucky the first time? Sure. There's going to be, we're going to learn some things tomorrow about changing the signs and finding out positives, upper bounds, and stuff like that. So that'll be part of the stuff for tomorrow. But for today, I'm going to make you guys struggle. You would only have to check them until you find it. There's going to be how many possible solutions here, guys? 3, because the degree is 3.
So do you have to find all 3?
You will have to find all 3. Well, first of all, it's not asking us to find the zeros. It's asking us to factor. So what would this look like now that I've just took out or divided out 2? x minus 2 and 2x squared plus 5x minus 3. Remember, it's because this is a remainder, constant x and x squared, correct? Now, what it comes down to, guys, I have a quadratic. Could you guys maybe factor that quadratic?
Yeah.
Could you use the quadratic formula? Yeah. So there's some things that we could do here. That's all fine and dandy. But then couldn't I just say, hey, could I use synthetic division with that quadratic and find another one? Here's a really cool thing about this, guys. I'm going to take out these letters that I put underneath there. And what if I said, I'm going to go again. I'm going to use what I just used, but now I want to get a 0 here. But here's the thing, guys. I'm not going to use my original list. And also, guys, we know 2 or negative 2 did not work, and 3 did not work the first time around. Do you think it's going to work the second time around? No. But here's the thing. I'm going to make a new list. What's my constant this time? The constant's a negative 3. So that's 1 and 3 over 1 and 2, right? So my next round would have 1, 3, 1/2, and 3/2. I'm down to 8 options instead of 12. Which is kind of nice. We know 3 doesn't work. Maybe, does negative 3 work? Let's test it. Bring a 2 down. 2 times negative 3. Negative 6. Add them together to get negative 1. It's 3. It works. So wait. So now we know that it's x minus 2 and x what? Plus 3. There's one more factor. What is that one more factor? It's 2x minus 1. Because of remainder, constant, x. 2x minus 1 equals 0. What is the actual 0, though? X equals 1/2. So you could use, instead of 2x minus 1, you could use x minus 1/2. That would work. But, guys, we just factored this. That's what the question's asking, is using the rational zero theorem to factor it. It didn't say list them. It didn't say what are the zeros. If it said what are the zeros, then I would go back and say 2, negative 3, and 1/2. This is just the list of the steps that we just did. List the possible zeros first, making the list, checking it twice, gonna find out who's naughty or nice, and then use synthetic division until you find an actual 0, and then basically it says in 3, repeat steps 1 and 2. Make a new list, find another one. Make a new list, find another one. Okay? It's exactly what I talked about. Now it's in writing. So, the last example we're going to do today is this one. Tomorrow we're going to go over how to use some different people's rules to make our list a little bit more manageable, or as we're checking to kind of organize ourselves. But today we're going to brute force a few things. So this one, I want you to find the zeros, and the hint, it says at the end you have to use quadratic formula. And 2, the whole reason, guys, of finding the zeros of a higher ordered higher order degree or higher degree polynomial is to find where it crosses the x-axis so you could graph it more accurately, right? We graphed these the other day, last chapter, by finding the x-intercepts by factoring. Now we're going to use synthetic division to find these zeros so we can graph it. So, I'm going to give you guys a minute or two. I want you to make a list, start finding some zeros, and we come together. I'm going to let some people take a stab at the iPad here. Okay guys, good question came up. Should we keep the trial and errors? So all of a sudden you say you check 3 and 3 doesn't work. Should you keep all of the work? I would say you maybe should if maybe you made a mistake in your algebra, or I would at least keep track of which ones you tried and which ones, so that way you don't try them again. At the very minimum. Okay? So, hopefully everybody should have a list by now. Who can make us a list and explain the list?
Recordings.
Yes, you are. You're live.
Okay, so we gotta take the P over the Q.
We're not going to have any room for anything else here, I see.
Sorry. And that, the factors of 10
Wait,
are,
why do you get 10 over 1?
because the 10 is the last number, or whatever it's called.
Okay.
Shut up.
Video now.
She said my handwriting looks like a second grader. Okay.
That's not very nice of one of you.
So 1, 10, 2, and 5 are the factors of 10.
Okay.
And then the factor of 1 is just 1. So that means that your possible answers, or possible zeros, are 1, 2, 5, and 10.
Okay, does everybody agree with Alex?
Yeah.
Okay. Thank you. Okay, so now that we have our list, Rachel, in her 3rd grade handwriting, maybe, is going to pick up the torch and give us at least 1 0.
Can I do the right one that I found?
Yes,
Okay.
go ahead. Guys, we gave us the time, so we have time. Hopefully we all
Yeah,
find at least 1.
I'm going.
So, using synthetic division, show it.
You can go with
It's
5.
0.
This is gonna be good writing. 1.
Would you please explain what you're doing?
Negative 5. Okay, so you look at the coefficients in the equation, which are 1, negative 5, 23, and 10. Yeah.
Did any placeholders?
Nope.
No
No
placeholders.
place. Okay, then you bring down the 1, and then 5 times 1 is 5. And then you have 0. 5 times 0 is 0. And then negative 5. And then negative 25. And then negative 2. And 5 times negative 2 is negative 10. And then 10 minus 10 is 0. So that's the remainder of 0.
Okay. I would say that's at least 9th grade handwriting. This is right. Is that 5? Is that the one everybody else found?
No.
Did anybody else find something different? Yep. Well, then please carry on and show us off of this using R's. Guys, here's the cool thing. Which one did you find?
Oh, I just found negative 2.
Okay, put negative 2 and now do synthetic with negative 2.
Okay.
Here's the cool thing, guys. The order does not matter. The resulting polynomial will be different because you're factoring out different pieces at different times. But if you had found 5 and, is it negative 2? Or 2? Negative 2. So if you do that, at this step right now, you will be the same. It doesn't matter which one goes first.
Oh, look at that.
Look at that. Everybody, if you found the 2, would have the same answer of x squared minus 2x minus 1. Would everybody agree with this? It'd be minus 2x minus 1 equals 0. Now, I could continue with synthetic division, but here's the thing. It's a quadratic. I put it back to quadratic form, and I take a look at 1. Because it's a is 1. What are the factors of 1 that'll equal 2? It would have to be 1 and 1. There's only 1 and 1, right?
Yeah.
But here's the problem. It's a negative 1. So what means 1 has to be positive, 1 has to be negative.
Yeah.
But if I add those together,
It's just not fact.
it'd be 0. So that's not factorable. Hence, up in the name, it said using quadratic formula. So at this point, I need you guys to take that quadratic and use the quadratic formula. Okay, guys, always write down the quadratic formula. I'll start this one because of time issues. X equals negative b plus or minus the b squared minus 4ac all over 2a. That's the quadratic formula. Guys, this will not result in nice numbers. But x equals the opposite of
2.
oops, my negatives did not follow me. Okay. So the opposite of negative 2 is 2 plus or minus negative 2 squared minus 4 times 1 times negative 1 all over 2 times 1 equals 2 plus or minus the square root of 4 plus 4 over 2. X equals 2 plus or minus the square root of 8 over 2. Is everybody with me so far? You guys better go to the square root dance and simplify that. So it's 2 plus or minus 2 times the square root of 2 all over 2. Which means that I can take a 2 out of the top. Yes? Factor it out. Divide it out. X equals 1 plus or minus the square root of 2. Which means 1 plus the square root of 2, 1 minus the square root of 2. Guys, those are the exact answers. If I was looking for an exact answer, you got to give me that. What are the zeros? 5, negative 2, a 1 plus the square root of 2, and a 1 minus the square root of 2. If I was looking for approximations, well, square root of 2 is like 1.414. So this would be 2.414. And if I subtracted it, it'd be something like a negative 0.414. Or not right? No, that's not right, is it? It is? Okay, yeah, that's right. So those are my zeros. Why is this so important? Well, first of all, let's back up and let's say, what if I asked you to factor that instead? Because you found them. This is part A. We just found all the zeros. But if I asked you to factor this, I'm going to erase some of this work so I can write here. Wouldn't you say that this would be P of x equals x minus 5, x plus 2? Wouldn't it then be x minus 1 plus the square root of 2? X minus 1 minus the square root of 2? It's not so nice, but that's using the exact numbers. We have irrational numbers. It's still real. You would have to eventually distribute the negative on both of these here, okay, to get this to look nice. But if I FOILed and multiplied all of these things back together, you'll end up with this equation. That's the cool part. Okay, the second part said graph this, or sketch a graph. So the reason I did this, okay, we know one of them's at 5. We know the other one's at -2. We know one of the zeros was at 2.4. And the other one was at about -0.4. We've done this last section. We found our zeros. What's the degree again? 4. Leading coefficient is positive. The shape is a W. And so, hey, wait a minute. We also should know by looking at the standard form, what is the y-intercept? It's at 10, so it's way up there. That means I need to. I'm going to change colors. Plug 0 in. It'll look something like this. Now, this isn't perfect. We know this. First of all, I missed most of my points. The other part, guys, is the fact that to help us understand where this low is and that low is, you may want to plug a point in like 3 or 4 to find down here. Or -1 to find where about roughly how far down it goes, right? There's things we can do to make this better. But we got a really good general idea on what the graph looks like. Homework on page 287, 1 through 7, 33, 34, and 43. Have a great day.